Now we'll see the factors which affects the electrolytic conduction. Factors affecting electrolytic or electrochemical, whatever it is, conduction. What are the factors? What are the factors necessary? The first is the nature of the electrolyte. Just now I was talking to you, nature of the electrolyte. Now nature of the electrolyte means when you dissolve a solute, alright, for example sodium chloride into water, that is the nature of the electrolyte. When you dissolve ammonium hydroxide into water, so ammonium hydroxide, sodium chloride, what are they? They are the solute, we can say, which is dissolved into water, that is a solvent. So in case of sodium chloride, what you find is that the force of interaction between sodium chloride molecule, one molecule of sodium chloride and another molecule of sodium chloride is, what you can say, strong enough, definitely strong enough. But when you dissociate, when you dissolve in water, listen carefully, when you dissolve in water, the high dielectric constant of water, alright, the high dielectric constant of water helps to dissociate the sodium chloride into its ions. Hence sodium chloride behaves as a strong electrolyte. But what about ammonium hydroxide? In case of ammonium hydroxide, what you find is that when ammonium hydroxide is dissolved in water, then the force of interaction between the solute and the solute molecules, that is ammonium hydroxide and ammonium hydroxide, is so strong that water cannot dissociate into its ions. If at all it dissociates very feebly. As I gave you the example, let us say 100 molecules of ammonium hydroxide you have taken it. The force between ammonium hydroxide is so strong that water is not able to dissociate completely into its ions. Hardly out of 100 molecules, let us say 20 molecules dissociate. Hence, ammonium hydroxide behaves as a weak electrolyte. So what we learned, that if the force of interaction between the solute and the solute is stronger, then it behaves as a, what you can say, a strong electrolyte, considering that on dissolving in water it dissociates into its ions. But if the force between solute and the solute is stronger but it does not dissociate into its ions when it is dissolved in water, then it is known as a weak electrolyte. So that is the nature of the electrolyte. That means in small word, in one word I can say strong electrolytes are the good electrolytes and weak electrolytes are the, what you can say, that is it dissociates very feebly. It does not dissociate completely. They are not the good electrolytes, the weak electrolytes. Because strong electrolyte, they are the good electrolytes. So next point is that, the next condition is that, the first one we learned about solute-solute interaction. Solute-solute interaction, isn't it? I said you. Now second one is solvation of ions. Solvation of ions. So here we are going to study about the solute-solvent interaction. The solute-solvent interaction. Alright. Now suppose if the solute-solvent interaction is stronger, just you tell me, if the solute-solvent interaction, let us say that is sodium chloride and water interaction, if it is stronger, means it is going to pull towards itself. So will it conduct electricity? No, it is not going to conduct electricity. Alright, definitely, because if it is stronger, that will not dissociate into its ions. Now see, children, one thing you understand it, you need ions for the conduction of electricity, because electrolytic or electrochemical conduction takes place due to the presence of free ions. Mind it, not electrons. Remove from your mind. Electrons is for metallic conduction. Alright, so if the solute-solvent interaction is stronger, for example in case of lithium chloride, when LiCl is dissolved in water, now LiCl, the solute which is dissolved in water, the solvent interaction is so strong that LiCl dissociates to a very small extent, compared to NaCl when it is dissolved in water. Alright, NaCl when it dissolves in water, it dissociates to a large extent, due to which this behaves as strong and this behaves as a weak electrolyte. So solute-solvent interaction should be stronger or weaker? It should be weaker. Solute-solvent interaction means when solute is dissolved in a solvent, it should be weaker. Then only it will dissociate. And how will you know? See, as the size, as you come down the group, you can see this has the elements of the first group I have written it. Metals of the first group I have written it. So what you find is that as you come down the group, the size of the atom increases. As the size of the atom will increase, the distance between this and this chloride, means sodium and chloride, is also going to increase. The bond length increases. When the bond length increases, the bond is stronger or weaker. For example, this is this bond, and for example, this bond. Alright, the pen, the cap of the pen, we can say that. It's a weaker, what you can say, stronger bond, because you cannot break it easily. But this pen, as you can see, it's a bigger bond length. Bigger bond length means weaker bond. Yes, I can break it easily. Clear? So hence, as you come down the group, the size of the atom increases, the bond length increases. Due to which, what happens? The bond becomes weaker and it dissociates easily. Hence, NaCl, the interaction between the solute and the solvent is stronger, but in NaCl it is weaker. Potassium chloride still weaker, we can say that. Clear? In this way, solvation of ions. Next is, that is, the third point is the nature of the solvent used. Nature of solvent used. Yes. Now here also, now first one, solute-solute interaction. Second one, solute-solvent interaction. Third one, solvent-solvent interaction. Alright? For example, sodium chloride, when it is dissolved in water, it dissociates into its ions because water has got high dielectric constant. Now, if sodium chloride is dissolved in kerosene or in alcohol, will it dissociate into its ions? No. Why? Because those substances, alcohol, kerosene, petrol, dissolve, they are the non-polar solvents. A non-polar solvent does not have high dielectric constant. It will not help to dissociate into its ions because the interaction between the solvent and the solvent, that is petrol and petrol, diesel and diesel, kerosene, kerosene, alcohol, alcohol, will be so strong that it will not dissociate into its ions. Hence, it will not conduct what you can say electricity. So, what we conclude then the nature of the solvent used should be polar or non-polar in nature. For electrolytic conduction, it should be polar in nature. That is water. It should be. It should not be non-polar in nature. For electrolytic conduction, we can say that. Remember that electrolytic conduction. Don't say, sir, it is dissolving. Dissolving, what will it do? If it does not produce ions, it needs to produce ions, and that to large number of ions. Suppose it dissolves to a very small extent and it gives you a very small number of ions, 10 or 5 or something like that. What will it do? It's a weak electrolyte. So you need to understand that not only it should dissolve, it should also dissociate into its ions. Then only it behaves as an electrolyte. So nature of the solvent should be such that it will help the solute to dissociate into its ions. So the solvent-solvent interaction, alright, it should be not so strong enough, alright, so that it will not dissociate into its ions. Alright. So hence, one more thing, one more factor, that is, we can say temperature. Temperature plays a very important role. Like in metallic conduction, you remember it. So if you increase the temperature, the metallic conduction decreases. Why? Because metallic conduction takes place with the help of free electrons. So when you increase the temperature, what happens is that the atoms and molecules which are present in it, they are also set into vibrations. For example, a copper wire is conducting electricity. At normal temperature, conduct electricity. Suppose you heat the copper wire. Do you think it is going to conduct more electricity? No. Why? Because electrons are moving freely at normal temperature. When you increase the temperature, that is, not only the electrons get excited, but also the atoms and molecules get excited. These atoms and molecules, alright, it provides a restriction to the path of the flow of current, and hence, what you find, with increase in temperature, the metallic conduction decreases. Understood what I said? These atoms and molecules, it provides restriction for the path of the flow of current. Current does not flow. Alright, why? Because resistance increases. Due to which, always remember that metallic conduction decreases with increase in temperature. Metallic conduction. For that reason, suppose the gadgets which you are using in your house, let us say your mobile or something like that, or suppose you can see the fan is moving throughout the day. When it becomes hotter, then its efficiency decreases. It may also have a chance that it may burn out. Alright, it may have a chance to burn out. For example, suppose now you are doing this online classes and all these classes. You see that your mobile becomes hot after some time. Now there's a chance that it may burn out. Got it? So hence for that particular purpose, what you find is that the metallic conduction decreases with the increase in temperature. But electrolytic conduction, our topic is electrolytic conduction, that it increases with increase in temperature. Because when you increase the temperature, what happens is that more of the ions dissociate. Because when you increase the temperature, the bond between the solute and the solvent, the bond between the solute and the solute weakens. So hence it breaks, and due to breaking of this particular, what you can say, bond, it produces ions, and these ions helps in the conduction of electricity. For that particular purpose, solid sodium chloride does not conduct electricity, but when you heat it, fused, molten state, you have read it in the lower classes, it conducts electricity, because in molten state, these ions are set free. Ions which was present in sodium chloride, in solid sodium chloride, was not free, but when you heated it, these ions are set free because the bond weakens and the ions are set free. Alright, hence electrolytic conduction increases with increasing temperature, but metallic conduction decreases with increasing temperature. So these are the factors which affects the electrolytic conduction. Thank you.